As in any word problem, you're reading to find the numbers, and then you're reading to find what you're supposed to do with those numbers. Cameron's grammar test had 100 questions on it. Cameron answered 92 correctly. What was the ratio of the ones he answered right to the number on the test? Well, we found the numbers. They stick out. But the question itself is asking for a ratio. So we're going to do a ratio of the ones he answered right. So this would be the right answers. They want to know the right answers to the number on the test. So the right answers to the number on the test. What does that mean, number on the test? Does that mean the whole? So we're actually looking for right answers, the correct ones, ratio to the whole. Now our numbers make a little more sense. 100 questions, that was the number on the test. That was the possible points that Cameron could have answered. And he got 92 correctly. So correctly would be our right answers. So he had 92. So our ratio then is 92 to 100. Or put another way, fractional wise, 92 over 100. Well, that's kind of nice because our denominator now is a column in the decimal side of our placed value. So we could say we have a percentage here of 92, or a decimal of 90.92, which turns into a percentage of 92%. What if our question was, instead of the ratio of the ones that he answered right to the number, the whole, why don't we change this to the number wrong? Now this changes the way that we're thinking about the problem. Our ratio now has to be thought of as the number right. So this is the right answers to the number of wrong answers. All right, so does 100 fit somewhere? There were 100 questions on the test. Did Cameron get 100 right? Did he get 100 wrong? Well, this answer right there doesn't help us at all. That number, we just can't plug it in like we did before. How about the 92? Could we use the 92? Well, that was the correct. He answered those correctly, so we could do our 92 here. But the wrong answers, it doesn't tell us how many he got wrong. However, we do have two numbers we could figure it out. If he got 92 of them right, then if we brought back our 100 and subtracted 92 from it, those would be the right answers, and this would be all of them that he could have. The answer to this subtraction problem would be the number that he got wrong. So we could figure out how many we got wrong, but we had to do kind of a side step to get our 8. Now our fraction is 92 eighths, 92 over 8. And this is definitely a top-heavy fraction, but we're going to reduce it via our divisibility rules, not get a mixed number this time. We just want to know right answers to wrong answers. So we can say that they're both even numbers. 2 is going to divide into those numbers evenly. I believe 4 does too. And yeah, 4 will work. So we're going to do our a 4 on this. 4 divides into 9 twice, with 1 left over, and 4 divides into 12 3 times. 4 divides into 8 twice. So we could simplify this ratio of 92 to 8. So we could say at 92 to 8 could reduce to 23 to 2. And that would be a ratio with an improper fraction.